Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to next problem in the exercise 3b, section 1, problem number 5. The problem is if a equal to I0, 0 minus I, b equal to 0 minus 1, 1, 0 and c equal to 0, I 0 and capital I is the unit matrix of order 2. Then we have to show that first problem a square equal to b square equal to c square, that is equal to minus I, and second problem ab equal to minus ba, that is equal to minus c. These two conditions we have to show. First, in this problem, we have to given three matrices A, B, C, and I is the unit matrix. We know unit matrix I equal to of order 2 is 1, 0, 0, 1. This is the unit matrix. In that first problem, A square equal to B square equal to C square, that is equal to minus I. For that, we have to find the square of A, B, C separately. These three values, square values, are equal to minus I. That means minus of this matrix. And also we have to find AB and BA, and we have to show the second condition. For that, first we will go to solution. Write down given matrices are. Given matrices are, first matrix A is equal to I0, 0 minus I, and matrix B equal to 0 minus 1, 1, 0, matrix C equal to 0 I 0, and unit matrix I equal to 1, 0, 0, 1. This is the unit matrix I. First, in that first problem, first we have to find A square and B square, C square values. For that, A square equal to A into A. That means matrix A into matrix A. Matrix A is I 0, 0 minus I into I 0, 0 minus I. After multiplication, first row in the first matrix, first column in the second matrix multiplied each other. Then I square, I into I square plus 0, 0 minus 0, 0 minus 0, 0 minus into minus plus I square, that is equal to I square 0, 0, I square. We know I square value is small I square equal to minus 1. That is A square equal to, here substitute I square equal to minus 1. Matrix is minus 1, 0, 0, minus 1. In this matrix, we take minus as common. Then minus of 1, 0, 0, 1. That is equal to 1, 0, 0, 1 matrix is unit matrix I. That is A square equal to minus I. A square value equal to minus 1. Next we have to, similarly we have to find B square and C square. Then B square equal to matrix B into B, 0 minus 1, 1, 0 into 0 minus 1, 1, 0. That is equal to 0 minus 1 minus 0 plus, minus 0, 0 plus 0, minus 1 plus 0. That is equal to minus 1, 0, 0, minus 1. Here also we can take minus as common, that is B square equal to minus of 1, 0, 0, 1. That is equal to minus I. Then we have B square equal to minus I. Next, we can calculate C square value. Next, C square equal to matrix C. C matrix is 0, I 0 into 0, I 0. That is equal to, multiplication is 0 plus I square, 0 plus 0, 0 plus 0, I square plus 0. That is equal to I square 0, 0, I square. We know I square value equal to minus 1, that is C square equal to minus 1, 0, 0, minus 1. Here also we take minus as common, 1, 0, 0, 1. That is equal to minus I. Then C square equal to also minus I. From above 3 conditions, we understand that A square equal to B square equal to C square equal to minus I. This is the first sub problem. In that second problem, we have to show AB equal to minus BA, that is equal to minus C. For that, first we can calculate AB value. AB equal to matrix A into matrix B. Matrix A value is I 0, 0 minus I into B value 0 minus 1, 1, 0. That is equal to, first row, first column, 0 plus 0 minus I plus 0, 0 minus I minus 0 minus 0. That is equal to 0 minus I minus I 0. Then AB equal to, here also take minus common, minus of 0 I 0. That is equal to, in the given problem, C value is 0 I 0. Then this is equal to minus C. AB equal to minus C can proved. Next we have to find BA. BA equal to 0 minus 1, 1, 0. A matrix is I 0, 0 minus I. That is equal to 0 minus 0, 0 plus I plus 0, 0 minus 0. That is equal to 0 I 0. That is BA equal to, this matrix is C. Then BA equal to C. Then minus BA is equal to minus C. Multiply minus with both sides of the equation. Then minus BA equal to minus C. From these two conditions, we can write AB equal to minus BA equal to minus C. This is the second subproblem of the fifth problem. Next, we will go to sixth problem, the same section. Next, we will go to sixth problem. The problem is, if A equal to 2, 1, 1, 3 is a 2 by 2 matrix and B equal to 3, 2, 0, 1, 0, 4. This is 2 by 3 matrix. Then find AB and also find BA if it exists. AB find and BA also find if BA is exist or not. Find out the condition. Then first write down the given matrices. In solution, given matrices are given matrices are matrix A equal to 2 1 1 3 of order 2 by 2 and matrix B equal to 3 2 0 1 0 4 of order 2 by 3. First AB and BA both are exist or not we can find. Then AB, that is A into B. A of order 2 by 2, B of order 2 by 3. Then AB is exist or not. The number of columns of a first matrix and the number of rows of a second matrix are equal. Then AB is also exist with order 2 by 3. Similarly, BA. B of order 2 by 3 into A of order 2 by 2 is equal to BA is exist or not. The number of rows, columns of a first matrix, the number of rows of a second matrix are not equal, then BA is not exist. Then in this problem we can only find the AB value. Then AB value is AB equal to A matrix A into matrix A is 2 1 1 3 into matrix B 3 2 0 1 0 4 is equal to first row first column 6 plus 1 4 plus 0 0 plus 4. Second row first column 3 plus 3 2 plus 0 0 plus 12. That is AB equal to 7 4 4 6 2 12. This is AB value and therefore BA is not exist. Is exist because the number of columns of a first matrix and the number of rows of a second matrix are not equal in matrix B and A, then BA does not exist. Next we will discuss the seventh problem in the same section 1. Next problem is problem number 7. If A equal to 2 4 minus 1 k and A square equal to O, then find the value of k. This is our given problem. In this problem we have to given a matrix of order 2 by 2. This matrix square is equal to O. O is a null matrix. If any matrices are both equal, the same matrices order is also same. Then A order is 2 by 2, A square order also 2 by 2. Then O is also 2 by 2 matrix. O is null matrix. Then by using these conditions we have to find k. First write down given matrix is A equal to 2 4 minus 1 k. Next we can find A square value. A square equal to A into A, that is 2 4 minus 1 k into 2 4 minus 1 k, that is equal to 4 minus 4 8 plus 4k minus 2 minus k minus 4 plus k square. That means plus 4 minus 4 get cancelled. A square equal to 0, 8 plus 4k minus 2 minus k minus 4 plus k square. And also given condition in problem is given that a square equal to O. That means a square value is 0, 8 plus 4k, minus 2 minus k, minus 4 plus k square is equal to 0, 0, 0, 0. We know one condition is that if any two matrices are equal to each other, then their corresponding elements are equal. Then by using that condition, here equate all the elements with corresponding elements, that is 0 equal to 0, 8 plus 4k equal to 0, minus 2 minus k equal to 0, and minus 4 plus k square equal to 0. But in this problem we have to find the k value. By using these three equations we can easily find k. Take any one of the equation. By our convenience we take this equation, minus 2 minus k equal to 0, that is minus k equal to 2, that is k equal to minus 2. This is the value of unknown value k. This is our problem solution. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.